All right, welcome back from lunch, everybody. As you can see by our conference, one of the hottest topics. This is the third talk that we're having on observability. Well, one talk briefly touched it because Jessica's talk showed a lot of pictures of Honeycomb. But today we have a CEO of Akita Software, Gene Yang, to talk to us about how developers can do observability in their application with one click. Here you go.
Yeah, thank you, Mark. Hi, everyone. I'm Jean, and I'm going to talk about different take on observability, how we can make observability easier for the developers out there that are maybe focused on other things. So I'm going to go ahead and share my screen. And if you're here for the beginning, you probably heard that I really like giving interactive talks, which is a little bit harder virtually, but we're going to try. So I'm in the Slack. I have the Slack open on my phone, and I'll look down periodically, during my interactive parts. If people want to respond, that's great. If you feel awkward responding, I'll just count to 10 in my head and move on. All right. So if you've gone to the other two observability talks at this conference, you probably know, the state of the situation with developers is most software teams are saying things like, we try to be good about testing ahead of time, but we often don't know what our systems will do until we run them. And so as much as people say, write tests, write types, write specs, write all these things, the reality is you just often don't know what happens with systems until you run them. And so observability is all about making it easier to do, to understand what's going on and do the right thing. The part that's additional that I'll talk about in this talk is best practices and even observability are very, very hard for most development teams. And so the motivation for a lot of observability is like people are saying, hey, look, the best practices in testing and coding are not working for us. So we need to do observability. What I'm saying is even observability is too hard for most software teams, and we got to do something else. So,
hey, Jean, 1 second.
Yeah.
You are showing your internal view to us, so we're not seeing the.
Oh, this is not working. Oh no. Hold on. I have slides. Oh, you have not seen my Taylor Swift slides? Gosh.
We have seen the slides. We've seen this the view that the presenter view. So we're seeing the slide and the next slide and the time that you've taken.
Oh no, that's not good. Okay. Let's try this again. Oh, desktop one. I see.
That's cool. It's all right. We saw. They're very cool slides.
Yeah. There we go. Cool. Yeah, good thing I have you. Yeah, real spoilers, huh? All right, so this talk is about building observability for 99% developers. So I'll first talk about the breakdown of the software development lifecycle. That's really what motivated me to go from working on programming languages to working on observability. In fact, the last time I spoke at Philly ETE, I was still I was finishing up grad school, and I was talking about a new programming language I made. I was really drinking the programming language Kool-Aid back then. I'll talk all about how I went from that to working on observability, because this might motivate some of you to look at observability at all or differently. I'll give a quick overview of observability today, but honestly, if you're interested in observability, you should watch Charity's talk or Jessica's talk. This is not the talk for your classic observability. Then I'll talk about how I got into observability, which was the tooling gap that my team and I discovered for what we call the 99% developers. And then I'll finish by talking about, how we got into building one-click observability, what that even means. Because to a lot of people, observability is like logs, metrics, traces. It's like a lot of clicks. So I'll talk about, what we're setting out to do. And yeah, if you have any questions or anything you want me to talk about or anything you want to hear about, just let me know. And looking at the Slack, thank you everyone for pointing out that that we were seeing the presenter view. Cool. So a little bit about me in my background. So I'm, unlike Charity or Jessica, I actually didn't spend my career in the software industry before working on Akita. I was working in academia. I was a professor at Carnegie Mellon University before this. And I was really, I had really drank the Kool-Aid of, better language design will save us all. So I'll talk more about that during the talk, but it's quite different from observability and really informs our approach to it. So I thought people might find this interesting. But I was working on programming language design, static program analysis, dynamic program analysis, program verification. It was really about if we just wrote enough proofs, we could save all of software. And I believe that for many, many years. I started Akita after a multi-year existential crisis of realizing that I no longer believe that was a way to save software. And I started just talking to developers in my network, and I listened to what they said, and I came to believe, one, observability is a thing to work on, and two, there are some gaps in existing observability that I'll talk about in this talk. And so hopefully in this talk, what I say will be helpful to anyone who's thinking about adopting an observability solution, or if you're having trouble with observability in your company, there may be easier ways. I'll talk about that. Cool. So I'll just start with the motivation of everything I do, and actually my motivation to leave programming languages, all that stuff, which boils down to the breakdown of the software development lifecycle. And I'll give a very my perspective kind of take on this, which is that, I came from the world of logic prevails. And yes, Heidi, I'm going to unpack 99% developer. I have a whole section on my discovery of this archetype. But the world of developer tooling I come from isn't even just let's put types on stuff. It's really logic prevails. So on the left here is a picture of Phil Wadler. He's a titan of the programming languages field. In programming languages, you might have heard it's, you're worshiping at the altar of the Lambda. Lambda is the Lambda function, functional programming. It's really about we can really design nice languages, design nice logics, then we can prove everything correct. And so, some of the beliefs of the world I came in were things like, if you make it easy for developers to do the right thing, they will do it. It's really the developer's fault. If they're not doing well, it's the language designer's fault, and then the developer's fault if the right thing doesn't happen. And that was something, that was a gospel I had believed for many years. Another part of this overall philosophy or cult I was part of believed, the right thing involves writing thorough tests. It really just involves measuring twice, doing the cutting once, very much that kind of philosophy. Using good programming languages helps developers do the right thing. That was also part of the world I came from. And then the dream of a lot of that world was to have fully verified entire tech stacks. And so what does this mean? It means some of you might have heard of the Curry-Howard isomorphism. This means, programs are proofs, and you need proofs of a program component. And so the belief was you can actually mathematically model all of your software, and then you could write proofs about what the software is supposed to do, and then that will be all of software. And so I see Mark looking at me like, what is this crazy world you came from? But I started to see some cracks in the world where I was like, man, the entire world uses dynamically typed programming languages. JavaScript is taking over, not Haskell. There started to be some cracks, but there are even bigger cracks. But to kind of give you the right context on how I came onto observability, I felt it was important for you to realize this very extreme niche thing that I was part of. And so first the first crack in what I was noticing was I was like, man, okay, so I'm part of this movement. We're trying to prove that everything's correct. And there's just so much code out there. So I'm assuming a lot of you have seen this image before, so it's not very big, but it's from Information is Beautiful. It's called Millions of Lines of Code. It talks about how, a million lines of code was bigger than the space shuttle. But now if we look at car software, it's 100 million lines of code. And so there were all these arguments in the field I was in that was okay, okay, sure, like most software maybe doesn't have to be proven correct anymore. We've given up, but at least like cars and like major operating components of our lives, we can like prove those correct. And I was like, well, I'm reading about how many lines of software are out there. And I think it's just like using logic to like make sure everyone writes in nice languages and then we prove all of that code written in nice languages correct. Like, I just don't think the world is headed this way. And so, like, in my defense, I first came to believe all this, like, 15 some years ago. So like there are not the sheer amount of code that exists now, but still you can see like, this like, we're going to specify everything from the top down, everything's going to be great kind of point of view. Just doesn't starts not holding up in the face of all these problems. And so this was like, stage one of my existential crisis. Logic won't prevail. And then I was like, oh my gosh, there's also microservices that are on the rise. And so you can see like, I started believing this sometime in the flat region. And so I was already like, man, there's like more and more lines of code out there. How are we going to prove everything correct? And then you can imagine my consternation when in about 2012, 2013, 2014, I start learning about these microservices. Because what this means is that you don't just have like a single monolithic thing that you have to prove correct anymore, but you have all these components that are talking to each other. And now you got to make sure like all those components are proven correct. Like, what the heck? And so so, that was the first thing where I was like, okay, I think, even if you're using like the right programming language in one place, what happens when you call somewhere else? Microservices make it easier to use like different programming languages across your system. I started, the grip of like, yeah, better programming language, better logical models, better everything is going to solve all problems started further losing its hold. And then, during this whole time, we also saw the rise of the API economy. And so for anyone who isn't like completely steep in the world of like programming, like formal programming language design or software verification, it may not seem like that big of a deal that there are like network calls to third-party services happening all over the place. So I'll just break it down really quickly here, which is like from like, especially the very extreme world I was in, any network call already subverts an application level guarantee. So if you imagine like, let's say you're using Rust and they're like, Rust is really, really safe. As long as you're in Rust, like everything is fine and no problems, right? And so, what enforces these things? The type system. As soon as you make a network call, what doesn't hold anymore? The Rust type system. And so now imagine like Rust plus, where it's not just like basic kinds of memory safety, but you've got like, I'm doing this correctly. Or like, let's say like, one of my early papers was actually about type safety in an operating system. And you can imagine like next level guarantees are like, we're actually doing the scheduler right, or we're doing, like memory allocation right. Imagine if like your type system, we're now guaranteeing that. And the minute you call out, it's just like a bigger level of, oh my gosh, like this is really bad. So to me, like this rise of, network calls everywhere was really like the beginning of like my major, like, I think like language level tooling is having smaller and smaller scope. And it's possible to kind of get around all this like stuff if all of your network components are homogeneous. So let's say like, yep, I have a bunch of microservices, but all of them are written in Rust, or like this like Rust plus thing where like, we just have properties everywhere. And sure, like network calls aren't typed, but we can kind of like, if we know the types everywhere, we can just like, marshal things in a typed way, unmarshal things in a typed way. That's fine. But the minute you have third-party APIs, these are black box. There's no guarantee of homogeneity. And I was just like, okay, any semblance I had that anything at the language level, so like any kind of language design, any kind of type system, any kind of like spec system, was going to be the solution to all of software being better, fell apart around this time. So you can see this graph, it was about like 2014, 2015 that I was just like, man, people writing monolithic spaceship software, maybe we can like plan to have everything be proven correct and everything be dictated in a top-down fashion. But what the world is moving towards is increasingly decentralized software development, more and more network calls facilitating this. So network calls facilitating service-oriented development, network calls facilitating API-oriented development. And so I was like, all right, we gotta, accept the way the world is. face reality. And then I came to see it as my mission to build tooling that actually met software development reality where it was. And that's how I stumbled upon the very opposite, the very, very opposite philosophies behind observability. So to summarize, the rise of APIs and SaaS make it easier than ever to quickly add functionality to a system. Implementations depend on how the components fit together. And so what we have is testing, like unit tests, integration tests. There's a reason why developers aren't writing more of them. And it's because they don't tell you everything that's going to happen in a system. And so, I feel like I come across a lot of software development teams that are very sheepish about their testing practices, but it makes total logical sense from my perspective. And then, there's also been a shift that I noticed. So when I was in the world of like, I'm going to like help everyone write logical specifications of what their program is supposed to do, then we'll prove the programs do this. And so whenever I talk to developers, they're like, Gene, this is great and all, but we don't know what our programs are supposed to do. And, like, according to the philosophies I've been taught, this is like a moral failing of software engineering. Like, how can you not know what your system is supposed to do? But if you think about, your software system is really this evolving, intricately codependent, interdependent web of services that are all exhibiting emergent behaviors depending on how they're interacting with each other. It makes total sense that there was no detailed intended behavior of the system. It really is what the system is doing. And so so I was in this world of like, we're going to top down specify everything. And I realized, oh my gosh, the real world of software is very, very organic, not controllable. There's very little you can actually specify. And my question was like, all right, how can I help still bring order to the situation if that's the case? So to me, it was an interesting realization was that the software development lifecycle had pretty much broken down, and one of my animations is broken. Okay, cool. There it is. So what's happened is, people talk about there's, you start with planning, then you do analysis, and you do design, implementation, testing, integration, maintenance. And then when you do, agile development, this all shortens, but this is still the stages. And the big thing that I was realizing was, hey, testing has really decreased in scope. Like this idea of testing before you run things, like there's like, does behavior even exist fully before you run things? Really unclear anymore. And so that was a big shift. And then design is much less top down and much more organic now. And so what I found, and, people may have different views on this depending on how, like, what tools worlds you're part of and what your philosophies are on tools. But a lot of the developer tools people I was seeing talk about development, even in industry, not just in academia, they were still thinking about tooling in terms of like these stages. And, first you write the code, then you test the code, then you run the code. Even though DevOps became a thing, there's like dev, and then we lob it over to DevOps. There's still very different stages. And what I really observed was, hey, actually, like every stage is basically maintenance. Like you write some stuff and then like you do a little bit of testing and then like the code is just there. And so most of what developers are really dealing with, or what they're supposed to be dealing with, is this like live running system with behaviors that you're adding to. What I saw was, a lot of non-observability tooling wasn't dealing with that reality at all. And a lot of monitoring wasn't really, giving developers nearly the same level of ergonomics and that kind of thing at all. And so that was a big part of why I was like, hey, this is something I could be working on. And there's a question from Rowan in the chat. Did the rise of ML also contribute to the loss of faith in top-down verifiable tech stacks? I think that's a really good question. I think the rise of a lot of things, including ML, contributed to this. From my perspective, I think the rise of ML contributed to like just like the kinds of non-verifiable or dynamically typed kind of YOLO code that's out there. Because to me, a big part of this was just like, here I was on the one hand studying these statically typed languages, these verifiable tech stacks, and here was the world. JavaScript hadn't taken over the world yet when I started this, which sounds crazy now. Like, I remember thinking, like maybe something can still overtake JavaScript as the browser language. Python was big, but people were like, it could disappear. Doesn't have the foothold it has today. And people, sure, they were using dynamically typed languages for web programming, but I think the jury was still out on some of this. And so, the rise of machine learning meant Python became more popular than ever. Scripting in these systems became more popular than ever. And I'm not a machine learning code expert, so I'm just making stuff up here. But a lot of the what I've seen is it's less like we're building like an operating system, but we're building like a big experimental system to like, I don't know, make new cat faces or something like that. And it just, you don't need to verify it either. It's a different kind of use case. So for me, major software practices went out the window. Everything I was teaching as a professor, everything I had learned, things like debug with a debugger, not printf. Like, everyone's debugging with logs now. Use type checkers and linters to help you catch preventable errors before production. These don't exist across APIs, like even basic, basic types that you have in languages less fancy than things like Rust. You don't have that when you go across the network. And then test your code on small examples before running the whole thing. When testing in prod is the thing, you just need a different set of practices, because what do small examples mean? Like our old testing practices have gone out the window. And so I developed 2 updated principles after years of existential crisis. One was that the world is very, very large. So I realized I'd been focused on application level tooling before that. And the view was like, what gets run is what you wrote in your programming language. And I realized, that's just not the case anymore. You have your runtime. And when you have microservices and APIs, like your effective runtime and, from like a security and verification are actually very similar. You talk a lot about your trusted base, like what you haven't like verified with your own eyes to be doing what it's supposed to do. Before like memory management, it was like you're assembler you're assembler in your hardware. And then as soon as you introduce memory management and language runtimes, you're trusting your runtime now. And then in today's world, you're trusting your runtime, you're trusting every other service inside your org, you're trusting every other third-party service that you're calling, and you're probably trusting a lot of other stuff too. And so if that's the world, like you can't go around proving everything correct. Like that's just not, like. And I bring this up not because I think there are like that many other people who came from such a crazy fanatical world as I do, but I see glimmers of this. People are like, oh, if you use GraphQL, like that solves all your problems, or like just use Rust everywhere. Those, like, I see it as like, step 1 towards end of where I was, but even step 1 kind of like doesn't have this world is very, very large, and you just have to like accept trusting a big part of your system kind of view. And so that was one of my new principles after I finished my existential crisis, and I was like, this is the world. And then my other principle is the only truth is what happened in the system. And so something I believed before was, look, developers like should write specs, could write specs, the specs could actually be true. No, I stopped believing this at all. There's there's like, I've had many fights with like people in industry and academia on Twitter about this, where I'm like, look, the spec is just what happened. And people are like, surely, like, you must have a notion of intention or anything like that. And I've actually come to a very extreme view, which is there's no notion of intention anymore. It's just like what happened, and did you like it? And so because I came to believe this extreme other view, the most important thing I thought I could be doing is building better tools to help developers understand their system behavior. And so how did someone who spent, 10 years of their life working on logics and like proving programs correct come to work on observability? This is how I developed these 2 new views. I really believe this is the most important thing we could be doing for developers. I think the future of developer experience is helping developers understand actual system behavior. This inverts a lot of how we've been building tooling tooling for developers. And I think, more of us should be working on it. So that wraps up that section of how I got here. And I'll give just a very quick overview of observability today, so that, people have some foundation of what I talked about, even if you haven't gone to Charity's or Jessica's talk. So you probably heard the word observability by now. As you can see, like Google Trends is just my source of knowledge on everything. The other day I was searching, like, is there a house bubble? So I went to Google Trends and they were like, bigger trend a few years ago. So I was like, cool, no house bubble, of course. But observability getting increasingly more popular. As Mark said, this is like a very hot term now. I always liked that meme where blah blah blah. Actually, it's not very safe for work. I won't say it, but everyone's talking about it. Is it clear that people know what it means? Not sure. And so this is not the best talk at Philly ET if you want to just hear about observability. So Charity gave a talk yesterday. She's a CTO at a company called Honeycomb. They've pioneered a lot of work on, what is observability in the first place. We're only able to do what we do by piggybacking off of that initial wave of defining observability. You can't make something easier if no one's defined it. Charity had this great blog post, when when I test in production. She has this great quote: once you deploy, you aren't testing code anymore. You're testing systems, complex systems made of users, code, environment, infrastructure, and a point in time. These systems have unpredictable interactions, lack any sane ordering, and develop emergent properties which perpetually and eternally defy your ability to deterministically test. And when I started reading Charity stuff, I was like, oh my God, this is like everything I've been having an existential crisis about. Because like I've been working on this is how you test your code better. This is how you write your code better. This is how you prove your code correct. But when you realize if that's all you're doing, your trusted computing base is everything else Charity talks about here, then it makes a lot more sense that, we should have much more tools for observability. And so, on along the theme of I'm not the best person to talk about observability, let me just throw up verbatim a slide from New Relic, another OG observability company. Observability is really about how well you understand your complex IT real estate. And so really, a lot of monitoring tools will tell you the symptoms, like your latency spiked here, or, you had some kind of issue here. But observability maps out everything that's going on and tells you, why this is happening. It's not just like, when is my latency spiking, but like why. And so if you look up observability, something that was curious to me is everyone will talk about the 3 pillars of observability as logs, metrics, and traces. So, you've probably, if you're a developer, you've developed with logs, that's the, don't debug with printf, but everyone's debugging with logs, kind of tension that I brought up earlier. Metrics, that's, debugging with gprof, if we map it back to the old days. And then traces are pretty interesting because they're really like, here's how this request mapped to this response, and traces are supposed to get at the why. And so a lot of the state of the art of observability is like, this is how you get logs faster. At Honeycomb, they're even building their own database to do that. This is how you get more logs. This is how you get logs from more places over your system. Same with metrics and traces. And so, to me, I was like, cool, here's like a whole space of tooling that people are working on that is helping developers understand their code. If it's good enough, I can just leave it be and just go on my merry way. But clearly I didn't do that. So foreshadowing. What I was starting to hear from developers was, managing logging and managing the logs themselves can sometimes feel like you're just inserting a statement here and then reading it back out here. And that is a big motivation for what we're doing. And even Charity will say no, the layer of abstraction you want to be at is the events. So, from a programming language point of view, where it's all about abstraction and abstraction barriers, logs, metrics, and traces are at a very quite low level of abstraction for where we could be. And so coming up, I'll talk about how, I even wrote a blog post last year about how observability isn't about logs, metrics, and traces. And on my team, we've had a lot of conversations about how the goal of logs, metrics, and traces is about helping developers understand the model of what's really going on in the software. And that model right now lives in developers' heads. Observability tools are manifesting logs, metrics, and traces. And the question is, can we get closer to manifesting the models themselves? But before I talk about that, I'll talk about how, I came to discover the tooling gap for 99% developers. And Heidi asked me, can we unpack 99% developers? Absolutely. And so one other reason I gave the context was like, unlike Charity or Jessica here, I didn't come from a background in industry before starting Akita. I had worked at Facebook, I had worked at Google, I had worked at Microsoft, but like they weren't super long stints. I hadn't shipped like a ton of production code. So what I did was I just went down my LinkedIn of every developer I met, and I just did a conversation with them to ask like, hey, what's going on? Like, how do you do it? What does it look like? And that's how I formed my understanding, because I was like, I've only seen what it's like at like the biggest companies in the world. Like, I'm sure it's different for most developers out there. And so I spent a lot of time talking to developers, and actually that's what motivated me to leave academia to actually start this company instead of like work on observability tooling in academia or something like that. So I started my conversations, and I thought I would just put this slide here as like a break from some of the more serious topics. These are actually two pictures from when I drove cross country I was living in Pittsburgh, Pennsylvania, very close to Mark's, Akron, Ohio. I was a professor at Carnegie Mellon, and I started having these conversations with developers, and I was actually like, I need to start my own company to build tooling around this. So I drove across the country. So the left picture, I think, is just outside Chicago. The right picture is somewhere in Wisconsin. But I put these pictures because I thought it was interesting that, I drove from not Silicon Valley to Silicon Valley. And during this time, I was having all these conversations with developers. A lot of the developers I ended up speaking with were not in Silicon Valley. And I came to believe, wow, like the center of gravity of development is actually outside Silicon Valley, even though I moved there to build tools. I thought that was a fun interlude. And so as I talked to developers, the big thing I realized was they kept telling me, we often don't know what endpoints we have. We don't know what happens with our endpoints. I started out, thinking Akita might be a data tracking company. So they're like, we don't know what our data is. But when I unraveled it, they were just like, we don't know where anything is. We don't know what anything's doing. And this was a common theme I heard across like all kinds of developers. And I was like, what do you mean? People told me that all these things are supposed to be best practices. And they're like, we don't do best practices. And so, I would talk to them and I'd be like, okay, like how much testing do you do? And they've been like, very little. And why is it that you don't know what your endpoints are? Didn't the developers who wrote the endpoints know what they are? And so I started uncovering a lot of things. So, I would ask them like, what's going on? You have all these tools. People told me all this stuff is supposed to be happening. And so what it turned out was I had just uncovered like all of the developers outside of what you normally hear from at conferences like this one, and like the developers who are blogging, and like honestly the developers I had worked with at Facebook, Google, and Microsoft, because the world I had seen was like, like when I worked at Google, it was like you have to do this test and that test and this many code reviews, and like your line can't be longer than 80 characters or it can't get checked in. So that was a very different world than like the rest of. Oh, sorry, my cat is on my keyboard. Hey. She wanted to contribute too. Here, I can show you her. Hey, Josephine, say hi. All right, I gotta go. And so what I found was like in most of the world, people aren't serving up like, billions of users or, whatever that number is above billions. So like the code doesn't have to scale. It's okay to pass your string as a reference, which I also wasn't allowed to do when I was at Google. But, you're not serving things at the same scale. Users aren't necessarily hitting all parts of your system with the same, at the same level. So like, for different kinds of needs out there, if you're like a small software shop outside of Fang, I guess it's Manga now or something, Facebook, Amazon, Netflix, Google, you just don't quite have the same needs. First of all, secondly, a lot of these teams are massively under resourced because you have you're not paying as much as some of these other companies, and you don't necessarily need to because you're not in Silicon Valley. But it's just a very, very different set of needs than what I had heard about just reading blogs, listening to talks, going to conferences like Philly ETE, that kind of thing. And what I learned was also a lot of what I had heard about in the observability space built on top of this, trickle down. This is like what Google did, or this is what Facebook did. And this is the kind of tooling that you should be adopting if you're a company trying to do observability. So I'll admit, I initially was really hesitant to go into the observability space because I was like, look, guys, there's like New Relic, there's App Dynamics, there's Datadog, Grafana, Honeycomb. And why aren't those tools serving you? And what I discovered was the tools are serving a power user community, but there's still a major gap for everyone else. And so what I discovered was that Scott Hanselman, who's I think he's a program director. He's like a Uber developer relations person at Microsoft. He has this great blog post about the dark matter developers. And he says, where are the dark matter developers? Probably getting work done, maybe using ASP.NET 1.1 at a local municipality or small office, maybe working at a bottling plant in Mexico in VB6. Perhaps they're writing PHP calendar applications at a large ship manufacturer. So fun fact, my mom actually is a software developer. And, when I was growing up, she was writing a large calendar application at the local company where I grew up in Pittsburgh, Pennsylvania. And one motivation actually for me to want to make software quality better is I was just like, all right, when there are bugs, that's when your parents don't come home for dinner. And so I was very familiar with this. There's people writing software all over, and often their practices are not what we preach in like the this is how your software should be, but this is just what the practices are. And so I was like, okay, there's a gap. How can I help you? So my updated take on the state of observability today is that there are great power tools for expert teams. So if you think about it, if you have a team that knows what the software is supposed to do, knows what you want your performance to be like, where you don't want errors, then you know what you want to track, how you want to track it. Then like these tools give you a great way to like insert logging where you want it, all that kind of thing. But if you want information out of your system you didn't predict, and so if someone didn't think to log in certain places or didn't think to make a dashboard, like our team comes upon this all the time, actually. So we're a 5-person team. We use Datadog, and all the time, like we get some kind of failure, and I'm like, all right, like, is there a, can we have a Datadog dashboard for this? My team, I trust my team. I respect them. I think they're some of the best engineers I've ever worked with, but they're just like, I haven't figured out how to make this Datadog dashboard yet. And we go months and months without ever having that dashboard. So, and so I've seen it myself, but if you want information out of the system that you didn't predict, it gets harder. And something else I noticed is some of the early companies that showed up to use us, they had, maybe 10, 20 plus years of legacy code. And so a big problem, I'd ask them, hey, like, why aren't you using Grafana or Honeycomb? And they're like, we don't know what our endpoints are because everyone who wrote most of these endpoints no longer works at the company. And so then you can imagine it becomes a lot harder to adopt some of these best practices that are like, when you write your code in the first place, think about how you're going to observe it, because like no one thought about how they're going to observe it when they first wrote that, PHP monolith that was supposed to be small 20 years ago. And so to summarize what we implicitly assume in our conversations about software development, there's often a lot of assumptions I hear about tech stacks being homogeneous. And this is something like I often talk with teams that are, looking to adopt like open telemetry. And they're like, yeah, we're just at the beginning of an open telemetry adoption. All we need is for like every person in our entire company across all of our services to uniformly adopt open telemetry. And so I'm like, okay, has anyone else uniformly adopted anything in your entire system? And they're like, okay, no, but it's going to be. And I'm like, okay, like let's just stop there. But there's this implicit assumption that even if it's not homogeneous right now, it will become homogeneous. Haven't seen it yet. Tech stacks are fully under our control. So people will be like, oh yeah, it's a mess right now, but like we're like converting over to GraphQL. So like I've had many onboarding calls where people are like, we don't need anything that you're going to give us because we're going to be on GraphQL. And then I'm like, okay, how much of your system is REST, gRPC, GraphQL right now? And they're like 98% REST, 2% GraphQL, or like 1% GraphQL, 1% gRPC. So I'm like, okay. So you are going to convert this to GraphQL, great. And then there's the assumption that tech stacks don't change much over time, which is like, okay, like we're going to convert to GraphQL, it'll stay that way. And, GraphQL came around a few years ago. Like, how do you know that by the time you're done converting, it's not going to be something else? And so, that's an assumption I see a lot. And the final assumption is people who write the code are around to test and maintain it. So that's that assumption I originally stated from the world I came from, which is like, if developers were just able to do the right thing, they would. But that's not like, if you have an evolving code base with an evolving team, it's not about individual developers wanting to do the right thing. There's a lot of practicalities. And so, back to Heidi's question, can I unpack 99% developer? I think like to me, 99% developer is like everyone for whom some or all of these things cannot hold, which is like, 99% of the developers I have encountered in life. And so, the reality of our software and tech stacks are like massively heterogeneous. I think like, actually, I would say like 100% of tech stacks I've seen pretty much are massively heterogeneous for a variety of reasons I'm happy to get into. Tech stacks are under nobody's control. And so, I think I've talked with people. So as I said, I come from a programming language design background. I actually wrote my PhD thesis on a new language for automatically enforcing privacy policies. So every now and then I'll get like, a CISO or CTO, they're like, Jean, I read your thesis. I'm going to like decree that my entire company does things in like this kind of way. And I was just like, are you sure about that? Because like I've seen this story go down so many other times. Like when I believed in that, I was going around evangelizing it and I was seeing what happened. And like I worked on a team like this at Facebook. They canceled our entire project. So good luck to you, but I don't know. And I think the other reality that I see some denial over is tech stacks evolve like crazy over time, because you see like people give talks and they're like, how I switched to GraphQL and it made my entire life better. And like the talk is given as if like this is the final thing we ever needed to do. It's never going to change again. But look, like every single tool has like a period, like some curve of when it's maintained. It like picks up popularity, then it's very well maintained, and then it like loses popularity. No one maintains it anymore. And so this is a big reason for tech stack evolution outside of anyone's control. And like your people are also going to come and go. Something else is going to be hot in 5 years. And so there's like, that is also inevitable. And then people who write the code often leave it without thorough documentation or tests, and that's fine. It's not a moral failing. That's just kind of how things are. And so, some of these may be very obvious to a lot of you. They definitely weren't obvious to me, especially when I first started talking. I think at this point I've talked with hundreds, if not thousands, of developers, and this was really eye-opening for me. And actually, when I talk with a lot of other tool builders, even if like when you lay this out, they're like, well, duh, that's very, very obvious. Often they'll acknowledge the underlying assumptions of how they're building the tool are not aligned with this reality. And so, to me, like I discovered this whole phenomena of 99% developers. And these were my main takeaways of how we should be building tooling. And so what that meant for me is, software is not really this planned garden. It's this evolving rainforest. I've used this analogy a bunch of times if you've seen my other talks. And so what this meant for me with observability was it motivated me to build tooling that can work as widely as possible across the components of a system. And so I didn't want to build anything that was specific to any one language or any one kind of framework. And so, people have asked me like, why didn't you just build for GraphQL, or why didn't you just build for Envoy? And I was just like, look, like every system I've seen is like some fraction of stuff. And so that was really, really important to me. I see a lot of, up and coming observability tools being like, all right, we'll give you like Kubernetes, we'll give you like a piece. And I think, everyone needs to start somewhere, but the ultimate solution is going to be, working across the whole thing. Something else that was really important was making tooling as easy to install and configure as possible across the system, because a lot of tools assume that, you're installing this as you're writing up a system. And that's just not true for most people. They've inherited systems that they can't really change. And that's increasingly true. So I think that there's always this view that like, well, that's less true because in the future, like people will rewrite more code because things will be better. Like, no, there's just more software accumulating, and like, why not reuse it? And then one use case that I didn't see a lot of people building for was observability for people who have inherited a mess of a system. And so I think initially, like our investors were pretty skeptical. They were like, okay, but like how, like legacy companies, how many, like that sounds very old. And I was sort of like, no, any company that's been around for more than 2 years has a mess of a system. They've had turnover. There's parts of their system that are really hard to instrument. So how can we build for that? And that set of constraints we identified on our team as like nobody else seems to be building for that. And so with the remaining time, I'll just tell you all quickly how we're building for that. But I really think that we're just at the beginning of all observability. It's one of those things where observability is hot for a reason. Like I don't think we're going to be the only ones doing this, and I think it's going to take a lot of different people doing different things here to make things better for developers overall. So I'll tell you how we're doing it, but like I said, this is just one data point among many. So the challenge that we set out for ourselves, and in case you're wondering, yes, every Taylor Swift picture that is from a song music video is a specific reference to that song. I picked it on purpose, but the challenge for Akita was one thing we set out to do was how far can we get with no instrumentation? And I've gotten into interesting discussions with Charity Majors from Honeycomb about this on Twitter, where she's just like, you got to instrument to shake out from your system what you need to. And my view is like, look, there's some developers that can't instrument for a variety of reasons. Code's too old, they don't have time, team's too junior, there's a lot of reasons. And so like we wanted to just like push the envelope. How far can you get not instrumenting at all? And the other question is how far can we get without asking a user to make any custom dashboards? And so like, yeah, eventually I wouldn't be surprised if we had like an instrumentation component or we just integrated with Honeycomb. Eventually I wouldn't be surprised if we had custom dashboards, but really like two major pain points that we saw across a lot of our users was, hey, like instrumentation is a friction. We have to like wait this amount of time and stuff moves, blah, blah, blah. The instrumentation, we have to keep that up to date. Depending on how fast you move, that's very hard. And then like our team just doesn't know what to do with this data. And so I also talked to lots of teams. They're like, I've got Datadog configured exactly how I want. Let me show you my like 20 Datadog dashboards. And I'm like, great, good for you. We probably can't help you that much, but what we wanted to do was help everybody else. And so the first part of the solution, as you may have guessed, especially if you went on our website, was to use an eBPF-based passive traffic listening approach. And so eBPF BPF stands for Berkeley Packet Filter. It lets you passively listen to traffic. And we ended up using subset called PCAP. And so they're like, we're not doing file system probes at all. We're just passively watching network traffic. And so the only footprint is the additional memory it takes to watch that memory, to watch that traffic. We're not like, inserting ourselves into the flow of that traffic at all. But this is a pretty cool approach because it basically lets a user theoretically start trying us out in 5 minutes. Obviously, like depending on if they know where their traffic is and stuff, it could take longer. But right now I'm working on a blog post with one of our users about how they deploy to prod by basically changing like a line of config. But it's a very nice approach. And because it's so nice, we're not the only ones. Like many other tools, Datadog has an eBPF based solution. A lot of other companies have, there are many startups that, are our generation, the earlier generation. There are a bunch of startups that take this passive monitoring approach. So that's that alone only solves the no instrumentation part. But like, where do you land? What was the second part of our question? And so, yeah, what we found was first, we're like, cool, we figured it out, guys. Like we had these users, we're like, we like did eBPF, here's everything. Like, here are your endpoints, here are like some other stuff we found, here, like, just like, you can read it all as logs, here's a graph. And then all of our users were like, what? Like, we came to you because we wanted to be less overwhelmed, not more. And so, and then they're like, well, at least when we were logging ourselves, at least we knew what our logs meant. Now we just have like this whole big, like, vomit. And so they're like, guys, come on, like we need to know what we're supposed to pay attention to. So they're like, maybe we like diff this or something, And so this led to part 2 of our solution, which is automatic traffic modeling. And this is where everything I told you about the world I came from and, like we analyze programs, that's where that comes into play. And so what we discovered is, hey, look, like our team's backgrounds is like, automatically analyzing program traces and programs for properties. You can kind of do the same thing with traffic. So we started taking network traffic, and the first thing we did was reconstructing it for here's the structure, here are the path parameters. Then we started doing like type inference because like the first 3 of us on the team came from a compiler's background. We're like, cool, anything you do with like a AST, you can do with like a network T. And so we started just like doing more API behavior. And so like we see our approach is like the antithesis of black box machine learning techniques. And so, like the like, thesis was how far can we get using structured compiler-like and program analysis-like solutions on network traffic? And so people have used this kind of thing a lot on like, compiler, like code, program traces, that kind of thing. We're like, cool, what if we threw techniques inspired by this on network traces? And so this is where we finally got to use our programming languages background. And so what we have today is we have a solution where we drop into your systems. We watch traffic automatically using eBPF. So you basically have to give us like libpcap access. That's the permission we need. We have a client that sits in our user servers. It watches API traffic. It's very low friction, relatively low risk. We actually don't send back any payload data back to our cloud. We only send request response metadata. So we've gotten around quite a few security teams that way. And what this means is you don't need to change code. You don't need to proxy. Actually, people have been like, Gene, you can't just say eBPF. You need to make a bigger deal about this. Like you don't have to change code. Some people say you don't have to change code, but you have to drop in a library. We had to do this for Datadog. It took our most senior engineer a whole week for our 3 services. Like we're not that big of a company. And so like, I guess there's like code changes and really no code changes, but we really don't have to change code using this eBPF based solution. And then we can drop into Kubernetes, we can infer a service graph. And then the really cool thing that we discovered was we can actually start alerting on changes because we model the API in a structured way. Like people started using like a diffing on our original like things we were giving them. And so they're telling, they're like, oh, I found this endpoint went away or this endpoint was new, but they're like digging through really like a lot of stuff. So we realized, hey, we can just tell you, we haven't seen these endpoints in a while. We saw this new behavior in this endpoint. We saw you were sending emails here before, but it's just regular strings now. We saw this performance change. And so where we're headed, and we're still in beta, is we want to be able to drop in to people's traffic. Like no one has to log anything. This like automatically stays up to date as the system evolves. And then we're a layer, we're somewhere in between monitoring and observability, because I'll say that, most observability solutions are like, it's very intentional. You tell us what to log and we log it. And so one way to describe the challenge we set for ourselves is like, well, types used to be that way. Like you tell us what type you want and we check against it. And then, type inference came along, and that really was responsible for the popularity of type systems and things like Python and Java. And so one way to think about us is like, can we do like what type inference did for some of these languages? Can we just infer what properties people actually care about to log, to track with these systems? And then we, keep this up to date, tracked. We keep, continually updated model, and then we can alert when things change. And so right now, most of our users are either have a fair amount of legacy code. So it's like, I call it like our low hanging fruit users, but definitely like 99% developers squarely, or like small teams without the DevOps expertise to have observability solutions. And this is very much who we want to keep building for. One day we think everyone will want easier observability, but I think for now, there's plenty of great observability solutions for people who really know what they're doing. And so we're trying to close the gap for teams that don't have time to figure out what they're doing everywhere. So I'll just give a quick demo. I know I'm like running very tight on time. And this is like I said, it's a beta, so this will all change, but this is our own API model of our own staging. So basically this is continuously kept up to date. This is, endpoints that are inferred from our staging environment. And so, this view is just like what is in my system at all. You can export this as OpenAPI 3, you can export it as JSON. But basically, this is something that a lot of people have shown up to our beta just to do, because they're like, I need an open API spec today. And we're like, cool, that's like step one of what we're able to give you. Some cool things are we actually infer a bunch of properties on top of your spec that you can then explore. Like, what has certain tokens, what has no tokens. And then there's a bunch of stuff that I think is really cool because it's just drop in. So we give you, a service graph. This is what's going on. This, like, you don't have to do any config for this. No additional libraries necessary. We give you metrics and errors just by, and this is us monitoring our own staging environment. But, this is all just drop in. And then the change report, hold on, let me refresh this, is the part that I'm really excited about, because since we have this information, we can tell you like, hey, this field went away. We saw that this was an email, but now it's email in string. We haven't seen these endpoints in a while. Is that, supposed to be the case? Here's some new endpoints. Did you know that you made them? Performance highlights, that kind of thing. And so in the limit, you can imagine, we're building the system where people can just come and let us derive more and more insights and kind of guide people along. And eventually people might want to, use custom, more bespoke solutions, but this is really like a much lower barrier to entry, we believe. And so I'll just throw up my last slide while people have questions, because I know I really thought this wasn't going to be that long of a talk, but I guess I had a lot to say about how I broke out of my cult. And so I'll just throw up this slide. Software development has changed. We need drop-in tools for observability. Observability is huge. Listen to everything Charity and Jessica say, and I think we can make it a lot easier.
This is fantastic. I mean, I love the fact that you just like, this is such a great selling point that you don't really need to do anything except that you need to just install one small thing on the host with a few permissions, and that it works with Docker and all this other stuff. That makes it much easier than talking to developers. And I think you're absolutely right. There are a ton of shops out there. Don't tell the first speaker who talked about ransomware, but they are running on quite old systems where you don't even know. I mean, I wonder if it runs in like Windows Windows server or whatever.
Yeah. No, we have a backlog of requests for like, Windows, like old Windows client,
yeah, old Windows machines.
like users who like are using Delphi. Anyway, we've seen a lot of stuff.
So we do have a couple of questions popping up in room A. What I would say, since we only have like a minute to go, I will say that yeah, feel free if you want to answer them, in the Slack, you can answer them.
Yeah, I'll definitely get to questions I don't answer here in the Slack. Sorry for leaving so little time for questions. I was like, I made it such a short talk. I was like, this is gonna be half an hour. But whenever I don't time my like tangents, that's when it gets dangerous. Does the tool have a way to dig down into errors and allow you to review individual errors? Robert, not yet. But that's something we want to either build ourselves or better integrate with other tools to do. Cause like what's next is an open question we have. Andrea says, has the information and insights you've given these 99% developer teams led to changes in their development processes? So I don't know if any changes we made in development processes yet, but we have led to people like modernizing their thing better. So they're like, oh, I had this endpoint, this needs to go away. I don't think we've been running for long enough to help people change their development processes yet, but that's the hope. We have run into a bunch of teams that say, oh, like we didn't even know what was in our system. This is a good discovery tool. Now this enables us to, layer more stuff, or now we can like export these endpoints into a gateway or, something like that. And so that's what we hope to enable. Although we hope also that like eventually we bring enough value that people don't just like move onto a gateway and never come back. Ron says, sounds like intrusion detection software to detect what's normal instead. Ron, that is a really insightful observation, because this is my last answer, but we actually started out wanting to build for security teams. And so they told us like we had to be black box, developers hate talking to them, like we have to be very easy install. And also the security teams didn't know the code. So they're like, you can't expect us to know what's going on. And so a lot of what we built was like initially for like helping security teams find where data was. What we found was like we would keep getting brought into meetings, and the developers would be like, wait, like if you can do all this, can you help us instead? And actually the security teams would be like, we already have kind of like very similar tooling. And so that like Ron, you're exactly right that a lot of like intrusion detection security principles were the foundation of how we got into building it this way.
Cool. I gotta cut off because I gotta start the next one.
Yeah, thanks, Mark. Thanks, everybody.
Thank you so much. This is great. I mean, there's such value in just like finding out what to delete, because people have this thing like, oh, are we gonna use this?
Yeah.
Like we keep maintaining it, and
too scared to delete anything.
And you find like it hasn't been used in a year, you could probably delete it or something.
Yep. Yeah. Thank you so much, Mark. I'll see everybody else in the Slack. Happy to talk there.
All right.
Yep. Goodbye.